Chemistry, Art Integration Project, on Packing of Solid State, presented by Gaurav Kumar Chaurasia. Let's start now. What is packing? Packing of spheres or constitutes particles, ions, atoms, molecules should be done in such a way that maximum space has been occupied and minimum space will remain vacant. Packing. It is of three types: packing in 1D, packing in 2D and packing in 3D. Coordination number. Coordination number is defined as the total number of nearest neighboring particle. Packing in 1D. In this arrangement, each sphere or particle is in contact with other two of its neighboring. Arrange in a row. The coordination number is 2. Packing in 2D. This packing is generated by stacking or placing the rows of close packed spheres. This is of two types: one square close packing and other hexagonal close packing. Square close packing. The second row is placed, as the second row are exactly above the first row, and this is aligned horizontally as well as vertically. This form is AAA type and its coordination number is 4 and forming a square, so it is called square close packing. Hexagonal close packing. In this packing, the second row is placed above the first row in a staggered manner such that its spheres fit in the depressions of first row. It is of ABAB type and the coordination number is 6. Packing in 3D. They can be obtained by stacking two-dimensional layer one above the other. It is also of two types. First is obtained when placing a second square close pack layer above the first. Thus this lattice has a type AAA patterns. And other type is hexagonal close packing. In the spheres of second layer of 2D, HCP is placed in the depression of the first layer and thus form ABAB type of lattice. Voids in solid states mean the vacant space between the constituent particles in a closed packed structure. In 3D there are two types of voids. One is tetrahedral voids. In cubic close packed structure, spheres of the second layer lie above the triangular voids of the first layer. Each sphere touches the three spheres of the first layer. By joining the center of these four spheres, it forms a tetrahedron, and the empty space left over by joining the center of these spheres forms a tetrahedral void. And other is octahedral voids. Adjacent to tetrahedral voids you can find octahedral voids. So now, what are octahedral voids? When the triangular voids of the first layer coincides with the triangular voids of the layer above or below it, we get a void that is formed by enclosing 6 spheres. This vacant space formed by combining the triangular voids of the first layer and that of the second layer are called octahedral voids. Thank you.